Okay, so welcome to the presentation of PeerfactSim.KOM. So today we will give an introduction on how the simulator, peer-to-peer simulator PeerfactSim.KOM is to be used, how to set it up, how the components are, and that's what we will present. So the agenda, so what is the structure of the simulator, what can you do with it, then how to download and set up the simulator in Eclipse, and then how to run the first simulation, how to evaluate it, how to look into the results, and in your setup to know what you give as an input and how to evaluate the output. Then we will go into the example of Chord to see how messages are created and how lookups are created and how the lookups are processed internally in the simulator, so how the message is sent, how it's received, how it is processed, and so on. And then we will have a look at a special protocol, which is Chord with malicious nodes, and to see how it is implemented, how you can implement malicious nodes in one overlay. Okay, so that's nice. Okay, so first of all, so where do you find it? That's anyway very important. Then you also find it in the first slide, so it's www.peerfact.org. There is everything listed. What's also relevant for us here in the room to participate in the simulator open hours, to choose when you want to meet in the week time, so that we have a common meeting day time if you have questions. So please visit that doodle and make your mark when you have time, when you would like to have the question hours. And with regard to the simulator, so let's go through it. So just some words about simulations in general. Then we will go into the simulator itself, and I will give you an explanation which elements are inside, and then we go through it and see how to download it, how to run the simulation, how to use this visualization, which is nice, but typically it's not often used. It's so just nice to see. But typically you run it in a headless mode without graphical user interface, and that's more important to see how to use the config files to set it up, how to get the results with the analyzers, and some examples. And the output is typically plotted with GNU-plot. That's why we will also see an example for that. Okay, so generally, how can you evaluate? There are typically three aspects. So one is analytical approach. There you have typically some models where you can show some proofs that your systems have some properties. Like for example, if you have a graph, a directed acyclic graph that's weighted, and you can give some proofs on the complexity of your approach, how much time it needs to set it up. But typically it's O log n or O of n, and it's just a rough estimation. And typical, so in praxis, you would like to really know what is the exact time. So when a lookup needs O log n, then you would still like to know whether it needs 1 second or 10. It's still a constant, but the constants are important. Okay, then what you also have is, besides simulations, so that I want to present the prototypes. What you can also do is to set up real networks, real PCs, combine them somehow in the network, like for example in the internet using a test bed, so-called Planet Lab, where 1,200 PCs worldwide are connected, and you can deploy your code and protocol on, and you can test the behavior. That's very predictable, very adequate, the model. So the internet is very real because you use the real internet, and you get very correct results. But the problem is often that you have very overloaded nodes in these test beds. So if you have 1,000 nodes and everybody's using it worldwide, then the results are not very correct, and 1,000 is also the maximum. So if you really want to evaluate large networks in peer-to-peer, for example, and to see how malicious behavior looks like in them with, let's say, 1,000 or 10,000 nodes, then you have to go for simulations, because there you have different models for the peer characteristics, for example, on the capacities, on bandwidth, how they behave. There you can test different behavior strategies, for example, 70% good peers and 30% bad peers, and to see how the effects are. And that's very nice, because you can do it on one machine. You get the results for 1,000, 2,000, 3,000 nodes with different aspects of malicious nodes, and you get the big picture of it. So what are the average response times? What is the traffic that is created? What is the impact of the malicious behavior? And you get also these real numbers, like the average lookup time with 10% of malicious nodes is, for example, 1 second or 2 seconds, or so you really have real numbers. That's why we look at simulations, and the simulation that we use is especially, this is just a picture that every research needs some evaluation. So what we use is simulations, and there are two types of simulations. First of all, there's what is a simulation? In a simulation, you have a node, and every node has its own state. So, for example, what kind of identifier it has, how many files it hosts, what kind of bandwidth it has. So every node has its own state, and they are somehow connected with each other and trigger each other with some action. So they send each other messages, and they react on these messages, and over all these reactions you have some emerging behavior, and you can see what's happening. And one approach to simulate is round-based. That's basically if you split the time in several slots, like in this picture, and every peer that has to do something in this time slot is performing its actions, and the actions only take effect on the next rounds. So that's somehow limited. What we look at are simulators, and the simulator using event-based, an event-based approach where every action has its specific time. It generates also some specific further actions, but nothing is happening at the same time. So it's only one action per one time event, and you have a timeline of events which is processed over the time. So one action after another, and every action can generate more events. So that's the main idea of how the nodes interact with each other. Okay, so just some words on the simulator that we will use and what we present in this presentation. It's PeerfactSim.KOM, and it started, it's a long history since 2005, since 7 years. The people have been working on it, and it's event-based. It's written in Java so that most of the students can use it. It's used in several places, and up to 100,000 peers are possible to simulate, but it also depends on how many events are generated. So if you have lots of peers and they only generate a few events each, then you can do it. If there are too many events, then it's not really possible. Okay, and the nice thing is it really supports the evaluation of peer-to-peer systems on various layers, so overlays or user behavior or just other aspects that you can have a look at. And it's also a nice framework that brings everything with it that you need for your own work to do, so most of the things that you need to evaluate. Okay, so just going through the structure a bit before going into the presentation, how to download it, how to use it. So first of all, how is it structured? There you see it has a layered component model. The idea is that on every layer you might have different implementations, and you can exchange them but leave the other layers as they are. And so you can, for example, if you have various overlays in the network, and the application, for example, is file sharing, then you can exchange the underlying overlays and still get comparable results for the same file sharing application running on several overlays. So these are the layers. So you have one user layer that's from the idea. You should have that. It's the idea is that you have various strategies and user behavior implemented. Then there are applications like file sharing. The service component is more something that's additionally integrated, that's not really needed, for example, replication in data storage. Then you have different overlays, and then the networking. We will see in detail what they can do. So first, starting with the underlay. So what is the underlay for? So it's the idea is that it is there to enable users to send messages from A to B and get real times for it. So what is the delay, what is the loss, and all that. So for example, if you have a simple network model, it just have simple calculations of latency between two nodes, no packet loss, no packet size or bandwidth, so very simple. It can be also more complicated. For example, something like the global network positioning, where the idea is that you have real measurements from the internet, where 100,000 nodes have been measured, and for those you have numbers on the latencies between each other and loss and bandwidth, and lots of information that you have. So this is based on measurements, and you can also make it more complicated, but it's probably not relevant for your work, but it's just nice to know what is also in the simulator. Because the internet itself is very complicated, so you have different backbones, different bandwidth, and there was an attempt to put this into a simulation. And so what you have also there is, just for this network model, different information on message sizes, on bandwidth, packet loss probability, that you can all configure, basically. So final slide for this networking. So what most of you will use. No, it's not that what most of you will use. This is basically just the statement that it's very relevant, really what kind of measurement you use for the network, but I just want to go to what is relevant for your seminar, and it's basically that you have two files in the simulator which define which is based on the network measurements, and which define how the times between two nodes are, how the loss rate is. The first one is the measured data, XML, that I will talk about soon, and there's another one, the modular measured data, and that just allows you to configure your network very precisely on fragmenting, jitter, and latency, and everything what is available you can modify. Most of you will use the default configuration. I just want to show you that it's very versatile what you can do. More important for you will be the overlay, where there are several overlays implemented, so unstructured overlays. There are distributed hash tables, like various implementations of Chord, CAN, and Pastry, and also some information dissemination overlays, which is probably not so relevant for you. So your work will mostly focus on the distributed hash tables, and most of the examples are related to Chord, but Pastry will be more relevant for you. Okay, so this is just an overview on the overlays that are in the simulator, and what is as a next layer available, the service layer, which just implements various applications that are somehow linked to the overlay, that can be used by the overlay, and there's some monitoring, some management, some replication, and finally, there should be an application layer as well. So the application layer that is somehow missing in this slide is file sharing, that is most typically used, or a lookup generator, just general one for DHTs. Okay, so just to finish the overview, what the simulator has. So it has this layered structure. It has also various useful tools with it. So this monitoring architecture, what it tells you is that every overlay has its own analyzer, and it helps you to see what is happening in the network. And in the simulated network, we will have an example for it. There are different churn models and nice visualization that we will also show. But just to see, there are lots of components, but most of the components that you will use is basically Chord or Pastry, and the analyzers that are relevant. And I want to go through you. So now I most probably confused you. That's why there will be an example, just to show you how to install it, how to run it, how to get a feeling for it, how you generate the results. So do you have in the meantime some questions? Probably from the examples it would be more clear. So so what is the first step? So first of all, if you want to have the simulator, go to the website www.peerfact.org. So I just do it in the meanwhile. So accidentally it's already prepared. And what you find there is an overview on just some news, and what's important is some simulator details, but how to download it. And there's also a new version, just released yesterday. So if you want to download it, just go to download, and there's also a quick start guide telling you how to do it. So you need Java and Eclipse, and you should download the current version of the simulator that we will do. Okay, And you need also to download these two network files that allow you to pick very realistic network models. Okay, also those we will download. Okay, then what's the next step? Okay, we have to unzip the files and place the two unzipped network coordinate files in the data folder. Okay, so let's do it. So we create first, we unzip it first. And we also unzip these two. And we take these two files and put them in the data folder of the unzipped simulator. Okay, so that's how it looks like. So now we need to start Eclipse, open Eclipse, and then we need to include it all. So let's do it. Where's my Eclipse? One moment. Okay. Good. So let's, how do we call it? PeerfactSim.KOM. Okay. So then I will copy the Justix, the unzipped folder in the new workspace. Okay. And what is the guideline telling me to do? New project, new Java project, and include it all. That's a bit too long. One moment. Okay. You want to have the Java perspective? Yes. Okay. So there are some warnings, but that should be it. Let's build it. Okay, where is it? So, did I want to show something more? Or did I want to pass it on to you? Okay, then I pass it on to Matthias.
Okay, now I will show you how to configure the simulator and start the first simulation. First of all, there are several starting ways. The most important one for the first access is the GUI runner. If we start this one, we see okay. Yeah, we see a GUI where we can choose different configurations which are included in the simulator. So, for example, we go in the visualization folder and there we find the Chord configuration. Then in the middle you find some parameters we can change here, for example the size or the finish time. But first we leave it as it is. And then we can start the simulation by pressing the button. And then we see the progress of the simulation. But this has a short error on it. I don't know exactly. We try the other config because this definitely works. So it's another config for the simulator, and we change a parameter, for example, because it's too big. So only 10 nodes on it, and then starting the simulation, and now it runs through until it is finished. And then we find the results in a output folder. There will be a new folder for each simulation you run, and in this folder you find different measurements. For example, here we have a DHT overlay dat, which counts the number of lookups done. Here, for example, you see the hop counts in the simulations. So it means that in average it durates 2.5 hops to get a lookup. And yeah, now the question is how to configure it. So we okay. Okay. Yeah. Yeah, you see here, for example, it's the time in minutes and seconds, and then you see the host, the number of initiated lookups, the number of failed lookups, the number of finished lookups, and the hop counts and durations. And this is produced by a special analyzer. We will look at it later. And you can also produce your own analyzers which measure different things. It depends on your needs. So if we look in the configuration we have started, it was called DHT XML. There you find different parts of the configuration. First of all, we have variables part where all the variables are defined. So we can change all of them. For example, in this case, we can change the overlay here, or we can change the net layer. Then there's a description part, and then are the different layers which were presented before are configured. So depending on the choose of the net layer, here's a modular net layer included. And for example, if we look at Chord, here's a Chord node included, and it's configured through a Chord node factory. Yeah, okay. Yeah, then we have also a seed because we want to have a deterministic behavior, and because of that we can configure here a seed, which is used to produce all random numbers in the generator. With the size, you can configure the size of the experiment. So in this case, at default we have 1000 nodes, but as I have done, we have had only 10 nodes. Then we have a start time for the measurement. So if you don't want, if you aren't interested in the joining phase, we can say only from the, let's say, 200 minutes on, we want to measure it. And the same is for the finishing time. Then we can also enable churn, so that the nodes leave and join over the time, and with a different churn model, for example the cat or the exponential churn model, which is included here. This next one we can configure as a net layer. So in this case it's only a simple net layer, but here we can also use the modular net layer or the GNP net layer. As overlays we can use different ones, so Chord, Epichord, Cademlia, Ken, or the centralized ones. Then there's also server flags, so some overlays included here. The centralized index and centralized storage needs a server, so it can be activated here. And optional, there can be included a service, for example, a replication service. And as last one, we can configure the application to use. In this case, it's only a lookup generator. It will produce default lookups every or random lookups every 10 seconds, I think. And we can exchange it with a file sharing application, for example, to get another behavior. All this defined things are configured in the whole application, in the whole XML file. And in addition, we have we have a so-called action file. And in the action file, there's configured what the nodes are doing. So we have defined different groups. In this case of the DHT XML, we have one group for all nodes. It is called all, and all nodes in it, so all 10 nodes, doing from the first second to the 120 minutes a join. So they join the network. They are random distributed over the time uniformly, but they are all joining until 2 hours. And after the 2 hours, at the 120 minutes, they all start lookups. So if we go back to the DHT overlay that we see it here, they are all joining in the first phase until we have reached 120, and from the 121, all are doing different random lookups and generate these outputs here. So now we can also work with these outputs and generate nice graphics of it. So for all the default analyzers which are included, you also find some GNU-plot scripts in it. So for example, if you take the DHT overlay, we have a DHT overlay plot file. And we must paste it to the output folder. So this is in the same level as the default one. Then I need a terminal. Oh, where? Okay, now when we are in the folder, we can use the GNU-plot file which is included. Now we have here some files. And for example, it shows the average duration and the hop count for the lookups. So here you see this 2 point or 1 point, the average over all generated lookups. Yeah, there are only a small example to run. So if we have an example of about 1000 nodes, we should have a hop count of about 4 or 5. Okay. Yeah, that's all lookups which are initiated. So here we see we have no failed lookups because I have used the simple net layer. They are all lookups and all messages arrive in the overlay. And yeah, all lookups are initiated first and then are finished. So you see we have an average about 15 lookups generated. We can also if we go back to the DHT config file, we can also adapt it. So we've used the not this one. We have used uniform distribution for the lookups here in this example, and in minimum 30 and in maximum 60 lookups. And we can change it to have a different behavior, so to produce more load or less load. And also, as I said before, we can also activate churn to get another behavior. So for example, if we use a cut churn model and set it to true, So now we get a new output folder. It's also the DHT overlay file. And if we now take the plot script as a new folder, we can repeat the procedure. And here we see an hop count. The hop count. That's a little high in this example, but here we see the initiated lookups and the initiated fails. So here we have not all lookups which are succeeded because of the churn. So, do you have any questions at the moment? Otherwise, we will go through the code and see an example of a lookup. So the lookup generator produce random lookups. So it's with a distribution, it produces lookups, and it is done through the node lookup method of the different overlay implementations. Okay.
Okay, yeah, before going through the code, I wanted to show some slides on how the internals of the simulator work. So we had this overview on how to download it. There will be also this video tutorial to see. So it's self-referencing on the website. So what you need, summarizing, you need Eclipse, you need GNU-plot, you need the simulator, you need to put the network measurements files in the data folder, and there's also Google Groups for if you have further questions that you find. So if you go on PeerfactSim.org, then you come on to the site. There's also a forum. So if you have some questions, you can ask them there. I hope that it's loading, but it for sure will. So, and anyway, documentation and watch tutorials. Okay, so that's what Matthias just showed. I just should have probably shown it before. So what you can do is to start a GUI runner. I'm not sure whether the run GUI is still there. Yes, still there. So you can choose from the list of config files those which are under in the folder of visualization that you can open, for example, to see how it works, and then you have this progress bar. I'm not sure. Should we try again to visualize? We must change something in the config. Okay, let's see what do we have to change. So where is it? So we have to first, we don't need that, and this can be okay in the config. So these are all configs. These are the visualizable configs. Chord XML. 51 nodes. Sorry? Yes, so monitor, default monitor. Ah, this one or all? Just this? Yes. Okay. Includes. Here. Okay. Good. So let's start again. Did we already add some? No. One moment. What should I start? Ah, good. Okay, so let's pick the DHT XML with did it had 1000 nodes? 51, okay. Okay. So now again, all actions are simulated, and so it simulates in the background what is happening, which nodes is communicating with which other node, and for the simulation there is a trace generated which stores basically this information, who communicated with whom, and that's why it takes longer and it's typically not used if you really want to get some simulation results. Yes. Okay, that's how it will look like. We will have a look shortly. I didn't, did I had to save? That's anyway not, okay. That cannot be visualized. That can be visualized, but that doesn't make sense. So let's take 20. Sorry? Good. Okay. So this is the visualization. And what you see is first you have to play the play button. These are the nodes also in which they are from the set world. And here you can customize the speed. Is it true? No. Where do I customize the speed? Okay, so now something will happen. So now you can see which nodes are communicating with each other, which message types they exchange, and so on. And what you can also do is, if this is basically the world map, how based on the geographical or latency-based coordinate model they communicate with each other. And if you switch to this other view, then you have the chord ring, which shows the circular space in which the nodes are located, and based on the IDs they are placed. So here you have the ring, basically the chord ring, and here you have the world map according to the delay coordinates. What else you can do? You can visualize all the relevant information per node if you are very interested in it. But as you can see, for 10 nodes or 20, it's quite nice to see. If you imagine you have 1000 nodes, that's not really something that you can take useful information out of it. Okay, so that's the visualization, but in most cases you will not use it. So typically you will use just the outputs folder with the DAT files. And like Matthias said, you get these DAT files, so how much how Chord evolved, how so just have a look in all of it. And what's most important, if you use the DHT analyzer, then you have the DHT lookup generator, then you have all relevant information for the DHT inside here. And especially for your cases, when you have malicious nodes, then it will be interesting how much of the lookups fail because of malicious nodes, and how the average duration or the hop count is increased because you have malicious nodes inside. So that's what will be interesting. And what I also wanted to show before going into the code is how it works internally. So this is again some bad screenshot of the config. So there's a better one, like it was presented before. Just what is important. So in the config file, everything is defined what is used in a simulator. So where's the source code? So like it is shown here. No, not here. One moment. In the DHT XML, so it just defines which elements are used, which implementations for the network, for the overlay, for the application, and that's very convenient. And if you go further, you have these actions files, like Matthias said, where it's written which group should do, either to join, to store, to make a value lookup, and what happens inside. Just before showing it in the code, there's also this short overview. What's important to know is what operations are. And an operation, that's some closed event that keeps state of one type of action. So for example, you have a lookup operation, and it has an execute parameter when it is, so every operation is scheduled for a specific time. So for example, for time A, it is scheduled, and then it should start, and then the execute part tells what should happen, and it's also typically also uses some callback when the result for it. So typically, if you send out a message and you get an answer, then the corresponding callback of the operation is called, so that you always handle the information corresponding for one lookup in one operation. But I think that's also what Matthias will show now in the code. Okay.
Okay, as already said, everything starts with a node lookup, and if we take the example of Chord, here everything started, and here's the first important part. The analyzer will be informed about the initiated query. And if you go into detail of the analyzer, so for example the default DHT analyzer, where we have seen the results so far. Okay, an analyzer is the thing which monitors all events and which produces the DAT files we have seen before. So if we here have the picture for it, so we have on the one side the simulation engine, and on the other side the monitor concept. Every event which is interesting, for example the initiating of the lookup, will be given to the monitor, and the monitor informs all registered analyzers. And the analyzers are registered through the DHT.xml, as we have seen before. And the visualization is also an analyzer, and because it was missing before, we hadn't seen any visualization, and by inserting it, it was registered to the monitor and also gets the events. Okay, and for example, the analyzer here, if it gets a lookup initiated event, it measures the starting time and increases the number of initiated lookups. And later it will print it every 1 minute, I think, and produces all relevant statistic. So if you need new ones, you can modify the analyzers or write an own one which measures all the things you are interested in. So going back to the abstract Chord node, it will produces with an lookup operation, which will be first initiated and then shortly scheduled immediately, as we have seen in the picture before. And if we go in detail into the lookup operation, we have the execute method here, where everything starts. Yeah, it will be see if it's self-responsible for the key it should look up, and if not, it will be search the next finger in his finger table, and then will produce a lookup message. A message is another important concept next to the operations. An operation is concentrated on one node, so the node which produces a lookup has a lookup operation, and to exchange and communicate with other nodes, it uses different messages. The first important one is the lookup message, and it will be sent through the translator, and all messages arrives at the message handler of the responsible of the receiver node, and there you see a message arrived method, and it will be distinguished between the different message types. If we look at the lookup message we have seen before, then here's only the handler lookup message method, and in it the node searches if it is self-responsible for this target. And if it's not the case, it produces a new forward lookup message and also informs the monitor about this handling. But if it's the case that the node is responsible for this node, it produces a lookup reply and sends this lookup reply back to the sender of the lookup. And in the sender, it gets the lookup reply in its own message handler. And here we see the lookup reply case, and then it searches for the responsible lookup operation, and the lookup reply will be delivered to the lookup operation, and there the lookup can be finished. So to get the result, and also the monitor is informed about the finish of the lookup, about the successful finish of the lookup. Yeah, and also it could be the case that there is a timeout which occurred, and this is also handled by the lookup operation. And for example, in this case, the lookup will be executed once more. So I think the max redos is 3 at default, and after that the simulator will be informed about a failed lookup. Okay, and as the last important thing, there are the operation finished and the operation the operation succeeded and the called operation failed method. Every operation has a callback. So if we go back to the beginning, where we have the DHT node, the node lookup where we have started, there can be defined a callback. And if the operation is completely finished, then the callback will be informed about a succeeding or a failed operation. So, for example, in this case, if it's a file sharing application which has produced the node lookup, then it can be informed about the node responsible for the lookup, and it can do something with the file, for example, download it from the node. Okay, that was a short overview about the handling, about operations and messages. Do you have any questions about it so far?
No, I also have some slides to inform you. To have another perspective on it, because it's to have another perspective on it, to have another person saying you the same, so because it's quite complex. So what did we see? So what is relevant is basically that's an overview on what is relevant. That overview you also find in the document for the documentation. So it would be so if you visit the documentation page and you go to the getting started with PeerfactSim.KOM, then you find also this picture and also the explanation on how the message flows are. So this is just a rough overview. And just to tell you what is important, so every node, so every DHT node supports this lookup message, lookup request and lookup function, and the things that you should know the concepts of the operation and the concept of the message handler. So the operations, what they do, they basically encapsulate and hold the state for one lookup. So if somebody asks the node to make a lookup, then this lookup is managed in this operation, and this operation is taking care that the lookup is performed, and if the answer comes, then it's also processing this operation. So what is happening, so this execute message is called when the time for the lookup is due. So because if you do I want to do a lookup, then you define the time when you want to start, and then you perform the execute at this time. And what is done there are messages sent to the other node, and some lookup messages sent around, so really to have a message sent around, and the messages are processed by the message handler, and they answer something back, and that's going back and forth, and messages are always handled by the message handler, until somebody finds himself responsible for the lookup request, and then the reply is also processed by the initial node, and it checks, okay, this is the lookup reply, that's very good. So the message handler tells the corresponding operation, which started also the lookup, that now an answer is available, and depending on the answer, the lookup operation performs the next action. So for example, either starts a download or tells the user everything is fine. So this is basically what is most important for in the operation of an overlay of a DHT is the operations that you should have a look at. So they describe what you can do, and they also maintain and maintain the state for every action for lookup, for example. And the message handlers are parsing and processing the incoming messages and decide what to answer on them. Okay, then we had the analyzers, like it was said. So the analyzers are informed every time something relevant happens. So in this case, for example, we have a lookup, a DHT lookup analyzer, a DHT analyzer, which is taking care of all the DHT actions. And it's always informed when something DHT relevant happens. So for example, a lookup is started, a lookup is ended, lookup is failed, then it generates, so it maintains the statistics on it. And periodically, it flushes the statistics to the files. And these files are like Matthias just said, they are listed, for example, so where is it in the code? Let me just see. So the statistics analyzers here, the default DHT overlay analyzer, which is implemented and informed by every DHT. And what is happening, so every time, for example, a lookup finished, then it is informed about who finished it, which key, which objects, and how many hops it took, and it creates the statistics. So how long did it take, how many hops were there, and in the end, when the statistics are generated, then periodically it is just written to the file what is the current status. And these files you find, like we had in the beginning of the presentation, you find in the outputs folder. But one moment, where's the outputs folder? There it is. So this is the outputs folder, and these files are generated during the simulation, and they describe, like we have here inside, what is happening over time. So this line specifically is generated by this output just by writing to the file the current statistics on all nodes. Okay, what I also wanted to say, so this is the analyzers and how are they initialized like the rest of the simulation. Like it was said, so if you have a look at the DHT XML, for example, then you have the analyzers for it. There should be the monitor. So this is basically, these are the analyzers that should be loaded. So this is with XML include, and if we go through it, is there some control and click, then you see what's all and activated. That's the visualizer, the aggregation, churn measure, connectivity, DHT overlay analyzer. So all of them can be activated, and all of them are informed with specific actions that are relevant for them. Okay, so this is for the analyzers. This was the example for Chord, how it worked. So just how it goes through the code. I'm not sure whether this is still valid. At least that was valid some months ago. So with how lookups are generated, how the event is executed, how the sent messages that are basically created here is handled, and how the analyzer is informed. And the important part is just that everything is in an output file, like we had seen before, and you can plot them with GNU plot scripts. Okay, that's what you all saw. And what is GNU plot? Because some of the users don't know GNU plot, so I'm sometimes surprised. GNU plot is a very nice tool to plot yeah, results and to plot statistics. So if you go into it, what is a GNU plot file? That's how it looks like. So you just can define, for example, here it is defined what should be the output, the PNG file, the file name, the X label, Y label, and out of the, let me just open it, the DHT overlay dot, it should use as an x-axis the second row and as the y-axis the fourth row. So it's the min is the time in seconds is the x-axis and the number of hosts is the y-axis, and this is almost correct. So what did I do wrong? Minutes and so time in minutes. So this one is the x-axis and this one is the y-axis. Good. Okay, and that's what you get. So the number of initiated lookups, and you can say, yeah, how to plot it, and also an app enhance, PostScript enhance, and as a PDF, and you get with GNUplot these nice results. Yes. Okay. Yes. Okay, what else did I want to say? Nothing on the simulator. So are there some questions on, there will be, so if you start using the simulator, then it's much quickly getting more clear what the operations are and how the message handlers are to be used. But it's just at the end of course, very simple to use. So just have a look on how Chord works and what the operation is, and basically just have to know that it all maintains for one lookup all the relevant information at one node, and the message handlers are handling the messages that are incoming, so they decide where to dispatch it to and how to treat it, and that's all you need. And at the end, once the lookup operation is somehow successful or not successful, or whether a specific message was arrived, you always inform the corresponding analyzers to gather the statistic to have some log on what's happening. And that is at the end put out in the file and visualized. So now what you also wanted to show is how to go through, how to implement or use malicious nodes in Chord. So how can you implement malicious behavior in the overlay and to analyze its behavior. Okay, so there I would pass on.
Okay. I think this will be a little bit more to your work than the part we heard before, because I think you all have to do with malicious behavior. And luckily, in the last semester, I had a seminar where I needed to simulate malicious behavior, and so there is some implemented work, overlay, DHT, Chord, and there should be malicious Chord. And the good news is you don't have to write every component new. There are just, let's say, 4 to 5 components which are really important for the work on malicious nodes. And these are mainly a node factory, the nodes itself, the message handlers, maybe some operations or messages, and if you have to do something with the routing table itself. So let's take a short look at the components. This is where all the components are in. So of course you have a malicious Chord node, and you have a Chord node factory. I think this wasn't mentioned before. The node factory is the thing that creates nodes. So you say, okay, we want 1,000 nodes, and the node factory creates 1,000 nodes of the same class. It doesn't do anything else just but this. But since you do not want only to have malicious codes in the network, but also normal nodes, it needs some additional parameter. So where do we have it? Yes, it has this ratio of malicious nodes, which is here. So you have to specify in the XML which you use for the simulation how much or which percentage of nodes should be bad. Let's say it could be 10% or 50% or 0%, which is a good network, and this should be in your malicious node factory too. And in my seminar, we implemented different behaviors. So our topic was we had Chord, and in Chord there should be different types of behavior concerning how messages are forwarded. Some nodes just never forwarded the messages, and some nodes just forwarded it in some wrong direction. So this is this parameter type of malicious lookup operation. So if you are doing this too, evaluating different malicious types of methods, you can do this easily by having a new parameter which you can pass through the XML file. This makes the work a lot easier. So this is the Chord node factory, which is not a lot to implement. And then you have the malicious node itself. And of course, it should extend the normal Chord node if you are working with Chord. If you are working with pastry, it should extend the normal pastry node, simply because, well, they should communicate with each other. If we have a malicious node in the network, it should be able to communicate with the bad or good nodes which are also in the network. And as you can see here, there isn't a lot which is written new, mainly two methods. Well, the first one is simply the constructor, because you want a new constructor which, of course, handles these different types of malicious lookup operations, which are here, and which doesn't do anything else. And, of course, the second one is, at least in this case, the node lookup itself. As Matthias had said before, the node lookup is responsible for looking for other nodes. And since a malicious node shouldn't look up for other nodes because he's doing something maliciously, here's it implemented that if what do we have here? Yes, if he is a malicious lookup node which doesn't forward any message, he does practically nothing. And if he forwards to the direct predecessor of the node in the ring, he just forwards it always to the predecessor of itself. And this is what you can do in this Chord node. And the next important thing is the message handler. And since we implemented different methods of malicious forwarding, we had to implement 4 different message handlers. So this is something you can't get around, sadly. But the good news here is again that you do not need to implement much. You just need to implement what can be done if we get a lookup message. Because, of course, you have join messages, you have store messages, and so on. But you are not really interested in them if you're just concerning for the lookups. So you just need to make a new method for what should be done with the wrong lookups, and this is do malicious handle lookup message. And in there, which node is this? To closest finger table successor. In this, he looks in the finger table and routes it at as far away as possible. And this is done in this code here. Something easier would be the no forwarding, because he shouldn't do anything at all. I hope. Yeah, do nothing. So this is really, really easy. If you get this lookup message, well, you enter the method and nothing happens, because this is what the node should basically do. So this is the find methods. Of course, you need to specify some operations itself, because for those malicious nodes, you need new lookup operations, at least in this case. But they are mostly copied from the normal lookup operations, so they just get different parameters and have sometimes a different execute method. But in this case, again, nothing really happens. So the monitor is called, that a lookup is failed, and the rest is just commented out from the original code, and that's it. And the last thing that you might need to do is, as Matthias said, write a new analyzer. In this case, this was not really needed because everything is in the normal DHT analyzer. You just need to, well, count the lookups, if you count the hops, I mean, because when you forward the lookups wrong, of course the hop count should increase, and this is already measured. And the second one is distinguish between finished lookups and failed lookups. And this is, of course, done again in the normal DHT overlay analyzer. If you are measuring something where you maybe adjust the finger table of some other node and you want to measure how often is this done or something like that, of course you need to implement another new analyzer or change the old ones. But this can be done very lately. So the most important thing is really the factory itself, where the nodes are created, and the message handler and the malicious Chord node, and or pastry node if you're concerning pastry. So these are the three most important components if you want to do something with malicious nodes. And I think that's it. Do you want to say? Yeah, okay, the lookup operations for the good nodes are just in the normal Chord. So in fact, the differentiation is just done. Where do we have the node factory? There. So we can go a little bit closer into it. No, that's the wrong one. There we have it. So what it does is it creates a random next double, and if this double is below the ratio of malicious nodes, we create a malicious Chord node, and if it's above it, we create a normal Chord node. So it's just flipping a coin, and we look at the value. If it's below the ratio, then we create this malicious node, and if it's above it, we create a normal Chord node. So this is where we distinguish between the normal Chord operations on the normal Chord nodes and the malicious nodes itself. Anything else? So again, of course, every operation, every message handler really extends the normal Chord classes. Here again, it extends the Chord node. The malicious message handler extends the normal message handler. The malicious operations extend the normal operations. So you always have that they really depend on what the original overlay does. And so this is the reason why you do not need to implement very much, because you can keep all the code that you do not need for the malicious ones, because, well, it's happening right there, and you just need to change what is really important for the malicious behavior. Some final words from your side? Yes. Okay.
Okay, so this was the overview on how to implement some malicious behavior. So just what you should keep in mind, most of the things are really done in either the operations, like the lookup operation, where everything is, all actions are started, or in the message handlers, where all messages are basically handled. So if you get an in message, so what to do with it, or in the analyzers where you do all the statistics. So these three big aspects are there that need to be touched. And because in the simulator there is already all the relevant overlays, like Chord is always a nice example to see, but there's also pastry, and it's easy to create just basically to extend it with a malicious pastry, let's say, and to change the components that, for example, take effect on the routing or take effect on what kind of information you give about your routing state to other nodes. So in some parts it needs to be changed, and then you can create these nice simulations on what is the effect of 10% of malicious nodes in the network, or 20% or 30%. And if you have any questions, so just visit the website, visit also the the website for the forum on how we can help you. So I hope this works now. Yes, it will work. And if you visit the forum, has been also used quite frequently to ask questions, and I don't know, Google is crashed. I don't know. And yeah, at least there's some Google. No, we don't want to show personal details. Okay, just visit it and it will be okay. And additionally to this forum, I would also like you to ask to participate in the doodle to find a common hours in the week where we can meet if you have some more questions. So, and if there are no further questions, so that's it for the recording, and it's time for questioning after that.